All right, boys and girls, welcome back to the drive-through. Hope everyone's having a great Thursday. This one took me a little while, but I got it, and I'm like, it's that feeling. That's honestly the best part of math and science is like there's an answer. So I looked at the answer, and I didn't get it, and I looked at the answer, I didn't get it, and I kept trying a couple things, and then I realized I just needed to think about why this problem showed up in this section. So let's talk a little bit about gravity first. I don't know what you guys know. Okay? Gravity is a vector. Negative 9.8 meters per second squared. So what that means is that every second this thing is going faster and faster. Now there is a terminal velocity, but we're not even taking that into consideration. So gravity, if you drop something, it starts out right before you dropped it, it's going 0 miles per hour. Every second that passes, that thing is speeding up. Does that make sense? Now, and this is an estimate. It's the same thing as negative 32 feet per second squared, okay? In this problem, we're going to be working in feet because that's where the answer key is answered it in feet. I don't care, and I can tell you most people in the world are using 9.8 meters. All right. Now, I think what you need to understand is, imagine if instead of dropping something that way, it was barely going down a slide with no friction. You would have to imagine that as this slide went from steep to kind of steep to kind of flat, that the particle moving down that thing would not have the same acceleration. Does that make sense? Okay? So all of these things are what I want you to understand before you start this problem. So then what I did was I obviously drew a picture, and this is called a free body diagram. This is a very popular thing. So they got this box. Now, bad box. Now, this box wants to go straight down, Brian. And so, that vector, we're going to call U, is 0, negative 32. Are you down with that? 32 is gravity, exactly. Okay? Now, I think we understand that what we want in this question, how much of that gravity is going in that direction? Okay? And at that point it dawned on me, this is a projection of U onto V. Okay? But we need to know, before we can figure out the projection of U onto V, what do you think we need, Brian? We do need V. I love it. We need V. So that's going to be our first step. Let's find it, okay? So, this right here is 32. Remember, we can treat it its magnitude is 32. We can treat it like a scalar. So let's find this. How would we find X? X being this right there. We would use tangent. Tangent of 40 is 32 over X, okay? Cross multiply and divide, and you get that X is, let's see, 30. Can you do this in your calculator? Do 32 divided by tangent of 40, you should get 38.13. You'd have to look, but it's 38.13, okay? Now, I want you to know you just figured out what V was. Because V is made up of two components, this one and that one, right? And so could you write down what V was? Let's see. V is left 38.13 and down 32. Does that make sense? And what we're looking for in this problem is how much of the gravity, U, is going in the direction of V. So if you shined a light from here, where would the shadow be from U? Project U onto V. Do you remember how to do this? So the projection, yes, of U onto V was U dot V over the magnitude of V squared times the vector V. Okay? All right, so it is, let's see, U dot V is 1024. The magnitude of V, remember, that's just the hypotenuse. That's the length of the hypotenuse. Okay? And I already did that. It's 2477.9. Okay? I'm sorry. That's the magnitude of V squared. That's the magnitude of V squared. You should definitely write this out and redo this problem on your own. And then what we're going to multiply that by is our V vector, negative 38.13, comma, negative 32. So far, so good? All right, so when you do the math on that, and I know I've been screwing up my graphing calculator, so I just did the math ahead of time on this one, you end up with negative 15.76, comma, negative 13.224. Okay? That's the direction and magnitude, that's the vector, the amount of the gravity going in the direction of V. So now, the question asked, find the acceleration. This is the acceleration vector. How do we just find the acceleration? Exactly, Brian. We're just going to find the magnitude of that. So that's going to be the square root of negative 15.7, dang it, 76 squared plus negative 13.224 squared. And when you pop that in your calculator, it gives you 20.57 feet per second. And I'm super pumped to figure that out. So now we know that, and that makes sense, right? Because if we just dropped the box, it'd be 32 feet per second squared. So the speed has been reduced by the angle, but it's still moving. Boom!